Good morning, everyone. Welcome to the next Ironside Take30 session. I see a couple people are still rolling in, but I'm going to get started on the agenda. My name is John Fellner. Been with Ironside for quite a bit here. You might have seen me in prior sessions or heard from me at some point. So welcome. And we're going to spend the next 30 minutes talking about how Power BI dataset refresh options and automation work. So we're going to quickly do an introduction, and then we're going to go through about 6 different types that we've outlined of dataset refresh, and we'll get into the Power BI REST API a little bit. We'll discuss something called incremental refresh, which I think is going to be something more popular as you build out more and more Power BI assets. And then we'll go through some real world use cases that Ironside has worked on in the past. Some of you might even be on this call. So you might look at that and see, hey, that looks like my environment. We won't name you, but you'll see, you might recognize some of these. And then we'll do a little bit of Q&A. And so I wanted to mention at this point, at any time throughout, if you have any questions, please put them in the questions or the chat box, and we can address those at the end of the session. Okay, so just to remind everyone that this is a series of Take30s, and we've been doing these for quite a while. We're wrapping up 2021 with a couple more. We have one next Thursday with a partner of ours called Keep It. And then the last one to wrap up the year is a pretty cool session for how banks utilize data analytics, hosted by our data scientist. And then stay tuned for more sessions into the new year. So quick introduction here. I have my colleague Susan Ma. You probably see on the other webcam here. She's been at Ironside even longer than I have, but we work together on a daily basis. Started working a long time ago, but more recently, the last couple of years ago, maybe 2-3 years, we've gotten heavily into the Microsoft platforms, specifically Power BI, but others as well. And so about 2.5 years ago, we became a Microsoft Gold partner, and we continue that. So both of us are pretty deeply involved in Microsoft projects. So we will be co-presenting this, but I'm going to start. Okay, so here are some of the options we're going to go over. You're probably not familiar with all of them, but most of you, if you use Power BI at all, are probably interested understand what the built-in scheduler can do in PowerBI.com. That one it's automated, but it's not triggered. So, you know, it's probably the easiest one to understand, but it's also the most limited. Then we have analysis services, which we're going to go into a little deeper, and also a discussion of what the Power BI REST API does. Something called Azure Logic Apps, data flows, which we're going to touch on a little bit, but there's going to be more. Probably going to do a separate session on that next year as well, because I think that's got some promising potential future to it as well. And then some discussion of third-party integration. Okay, so the built-in Power BI scheduler, it's at the dataset level. So if you're familiar with a dataset, you can go and control when you refresh these Power BI datasets. With the standard licensing, or actually you need a pro license, but these days pro is pretty much what you need standard to run things at any sort of administration type capacity. They're maxed out at 8 refreshes per day, which is adequate for most people if you're having to schedule something throughout the day. But there are others that like, you know, more real-time access to data, and that is available with the Power BI Premium licensing or capacity. So, you know, more frequent refreshes are available. And this isn't just with a scheduler. This would apply to the API as well, but I'm listing it here just so that you know that there is a difference between the licensing levels in terms of how frequently you can refresh. It will send you failure notifications. You know, you can send it to the dataset owner or to other designated contacts. But again, this is not a triggered event. This is just a scheduled event based on your time zone or whatever. It's not tied into any ETL flow. So therein lies kind of the problem that will allow us to explain some of the other ways that we can refresh data sets that are more tied into your overall ETL process. Okay, so one option is we have analysis services. As some of you may know, Power BI is really built on the analysis services engine anyway. So when you build a Power BI data set, it's really built on analysis services as a tabular model. And those tabular models technically look like databases. If you were to open them with Microsoft SQL Server Management Studio, you could point right at them and you can control the way that they refresh. So you can do a full refresh from Management Studio. You could also do an incremental refresh. So there might be a case where certain tables take a long time to run, and you also don't need to refresh them as frequently. So maybe you do those weekly, but others you might put on more of a daily refresh schedule. So you can control some of that here. You can also accommodate multiple data sources, right? So maybe you've got, a cloud database, but maybe you have an Excel, template or something that you upload, budget numbers into from or something like that. So you can control that from here, and you can see all those represented as tables and data set when you upload them. You can also generate a script, and you could use a tool like PowerShell to control that scripting, and you can also tweak those scripts as you see fit. Now I'm going to hand it off to Susan, she's going to talk about the Power BI REST API.
Thanks, John. So Power BI do have a full REST API for you to leverage. The scenario you're going to use program interface you want to do, for example, trigger driven, or if you want to integrate with any other application you have to fully automate the process to refresh the data. So essentially, at high level, this program API supports any programming that support REST API. For instance, .NET, Python, even JavaScript, you can do REST API directly as well. The basic requirement here is, number one, you have to have a pro license, right? I think everybody have pro license, right? You do have to pre-set up this account in Azure portal first to give enough permission, right? You have to refresh the data set, essentially read and write the data itself. Limitation, I think John already mentioned. In shared capacity, you only have 8 in total per day. That do including the one you scheduled from the GUI. So both API and scheduled from GUI account together. Premium would be much better. You can have pretty much unlimited API refresh. However, if you do have a large data set, the API do not prevent you to do refresh, but you may be constrained by the resource. For instance, the server itself, maybe, have some limitation. Making the call to the API pretty simple. You just make a post request to the server. The UI posting here, very simple. Passing either your dataset ID, or if the whole entire model, it's passing the model ID. Once you send the request to the server, it will return, the response code. 202 typically will be successful. If you get a 404, it will be failed. So to make this URL calls, you do have to first establish the access token, which means you have to log in Power BI first, right? Because the data set is already saved on the data on the server cloud. So you have using whatever built-in APIs allow you to do the authentication token first. Okay, so that's the API. Let's go to next. I think today a lot of people using Azure platform very dramatically, right? So this is one of built-in cloud-based app you can use to schedule data refresh. The best part for this is you don't have to do any coding, right? Compared with the other programming interface, this one no coding at all. You just click configure the process. So essentially similar to very similar to a ETL or job scheduler you have. It's Windows based. You just click go through the workflow. This building app actually allows you to connect to 400 plus Azure-based ecosystem object. You can connect to database, you can connect to email, you can connect to Office 365, everything pretty much. Azure Windows-based application can be connected to this unified workflow interface. You do have pretty good built-in schedule. You actually can schedule directly from here, similar to the built-in data refresh schedule as well. You can get an email notification as well. Okay, let's look at the next one. Incremental refresh. This is a very new feature added in. I think it's a very welcomed new feature, right? So similar to database, right? You can have big, large, tables in a database, right? When you refresh a data set, that you may have scenarios that you have very large tables. You don't want to refresh every day. All your data doesn't change every day. You want only, refresh those changed. So it can, reserve your resource or make the refresh much faster. So common user case will be you want shorten refresh time duration, right? Let's say you have 20 tables in your data set. You only want to refresh certain ones, or you want to refresh the one actually being, changed, right? It makes this data refresh much reliable because the time reduced and also reduce the load on the database side, right? Less resource consumed and also can make your easy setup, right? The requirement for this incremental refresh will be you have to have a parameter set up in the dataset itself. Essentially, you have to tell the system which set of data you want to look at. How do you define which one's old, which one's new, basically, right? Very similar concept to database table, refresh. The database must support the query folding, which is featured in most advanced database support. So essentially, it basically tell you on the database side which data being changed, which one can be refreshed based on this parameter setup. So if you do have flat files, blob, or any other like a web-based API data feeds, that means you cannot use this feature. Time limits, you only limit to up to 2 hours if you only have Pro, like a normal data sets. If you have Premium, you can do up to 5 hours. So to configure this one, you can using PowerBI built-in like a desktop, configuring these parameters. You also can using Tableau Edit, which is third-party tools to make those parameters set up in the dataset itself. This will be very useful if you actually lost, your, let's say your Power BI report dataset file. You cannot download to cloud environment. You can try this Tableau Edit. Very easy, handy to use. Okay.
Thanks, Susan. All right, we'll jump back over to me for a little bit. I'll talk about data flows. So this feature's been around a little bit, and it's actually decoupled a little bit from Power BI, but it's part of the Power Platform. So as you know, Microsoft's trying to brand, Power Platform as being a suite of tools rather than just a few of them. And this one is something we plan on having another session next year to dive into a little bit deeper. But Power BI data flows can actually, if you go into Power BI desktop, you can see it's one of the available data sources that you can build a report from. And it kind of insulates the end users from kind of doing a lot of extra, more damaging things like pulling in files or directly connecting to databases. And they don't necessarily need a whole bunch of different credentials to get into data sources to do it. It's built on top of Power Query. It's actually, Power Query is a tool that predates Power BI, and it's actually kind of like the metadata engine really underneath Power BI. Not really an engine, but it's more data prep, where you pull in all of your data and you do some transformations, a little bit of data profiling. And so the nice thing about that is, you don't need to have somebody who's really familiar with report building to be able to set these up. It's more of a data engineering task, sort of a light ETL kind of feature. So again, it'll insulate users from needing direct access to those data sources. It'll help you centralize some of the queries. one of the examples somebody gave was that, well, what if you have a date dimension that you refresh, but it's not in your database necessarily, but it's pulled into your data sets. So let's say you update what month to date and week to date and year to date means every day, and you put flags in it. But it's shared across multiple data sets. Well, instead of building that or pulling it into every data set, you could just centralize it as a data flow that could be leveraged by anybody in the organization that you want to have access to it. It allows the separation of refresh schedules for different data sources or individual tables. So again, similar to what we've said in prior slides and other techniques, you can schedule different tables and different sources at different times. Some of them that are long running, you might want to do overnight, and other ones you could do at different times or more frequently during the day. It's technically, the data is stored in the Azure Data Lake, but it's all in the background. It's not something you have to worry about separately. There's no subscription needed outside of having a license to just build data flows themselves. Once it's refreshed, you can use Power Automate. This is kind of a newer feature. You can use Power Automate, which is another part of the Power Platform, to kick off the Power BI dataset refresh. So it's a little bit upstream from the Power BI dataset, but it can feed a Power BI dataset, if that makes sense. So again, we're going to try to do a session next year on this, so stay tuned for that. I think this is going to be an exciting feature that it's going to give you some flexibility in the future. Okay, so next, last but maybe not least, would be third-party integration. Mostly, we're going to leverage the REST API that we already talked about. We have an AWS example that we're going to show you in just a minute. You can also tie in, outside job scheduling tools, title controlling, Google Cloud Scheduler, et cetera. As long as they can work across the REST API, they can be leveraged. And then other options would be like calling a script from your ETL, your database, et cetera. There's a lot of different examples that we just wanted to point out that it's not, you're not limited to just Microsoft tools to be able to control the refresh of your data sets. So again, I wanted to remind everybody to put questions in the chat if you have any, but now we're going to go through some real world use cases. I'm going to start and then Susan's going to do the rest. So this is a use case that's very recent. We used AWS, an AWS solution to kind of control all of this. So it's Lambda functions. If any of you are familiar with AWS, I am not. So that's about as far as I'm going to go into detail about what that does. But basically, it's also an all cloud solution where we have a Snowflake database and we have Matillion, which is a cloud-based ETL tool, and that loads the Snowflake. But we get a message from Matillion when the Snowflake tables have loaded successfully. At that point, we can get the end of ETL process message, and we send it to another Lambda function, which calls the Power BI dataset refresh across the REST API. That one's nice because it's kind of self-contained, and we're able to refresh our dashboard at 2 in the morning instead of trying to put it on the scheduler at 6 in the morning. And again, if something had failed in the ETL process, we may not have caught it, and we would have refreshed that data set for no reason and wasted database query time, which is important when you're working in cloud consumption models, right? Because you're paying for all that stuff when you have to fire up Snowflake and run a process. So this was a nice recent example that we did. And now I'm going to hand it over to Susan for a couple more use cases.
Great. So this use case is a customer, they deploy their model fully into Azure Managed Services instance. So what we did is we published the model to Azure instance first. They do have data source sort of locally. So what happens, we have to set up a gateway. Through the gateway, you can upload the data to the Azure cloud system. So a couple of key points here. First of all, they do have a master scheduler, right? Everything has to be triggered by something. They do have an ETL master scheduler to kick off the entire ETL process. this data table model refresh will be the end of process. So similar to the one John just mentioned, this is part of ETL process. The data refresh won't happen until all other tables being refreshed. So you have a continuous process without interruption. You don't have to waste your resource, if something didn't happen, right? So what next here is, once the ETL finished our data refresh here, we're using .NET. This is the choice they pick. The language they have to support their environment. So the model itself has very complicated low-level security as well. It's sourced from different tables. So what happens is we're using API to call the refresh. In this case, we're using full model, which everything will be refreshed every single time. You do have option to select any other model we mentioned in prior slides. Again, this is API calls. You have to log into the same way you log in from UI, even though this is API calls. Once the token generates, we go into the local database, grab all the table data, and then upload to the cloud Azure instance. So the report itself just automatically refreshed once the model being refreshed from the Azure Azure services. So the entire flow is fully driven by the master scheduler. We do not have worry about whether if ETL failed or if ETL didn't fully complete, or middle of the night you have to wake up. So this is within their programming team to maintain. They already have done a developer, so you don't have to do anything extra. Very nice feature. Okay, let's look at the next sample. So this one using the newly released XML endpoints. Similar to the REST API concept, this will be programming-based dataset refresh. And in this particular user case, we got this customer using SQL. The ETL process is mostly driven from the SQL agent. So what happened is you get all the tables data on your local environment. You get a step one. You first refresh your source tables, and then once they're finished, from the SQL agent, you can call a PowerShell. A PowerShell, behind the scene, can be directly called by Windows Bash script as well. So once that kick off, it goes through similar process. In this case, same thing, because the data is hosted locally. You go through the enterprise gateway, upload the data to the dataset, which is hosted in PowerBI online services. So pretty similar. The only difference here is you have full control of either full or partial or default. You also have very detailed control to the table level. In this case, you can refresh either all the tables or select, just certain tables. This particular user case, they actually refresh different tables at different times. As we mentioned in the prior slide, right? You may have large tables only refresh every other day. You may have, small tables refresh every single day, or twice, 3 times per day. This will be perfect user case. So far, this is the most kind of fine, option you can do using programming, interface. It gives you option to do any refresh options. It give you control to do either full model or go to any single table. Okay, let's look at the last sample. Azure Logic Apps, which you mentioned, right? You just click config through this cloud-based flow. In this case, you have a similar masterbook flow setup first. This customer also do similar process. They configure all the ETL process using this app logic, right? All the table refresh first, and then they at the last step they add in this dataset refresh. Similar to other customers, this customer also publishes their model to Azure Analytics Services. The full model published there. We're using just a connector from Azure Logic Apps. So not coding, you just copy and paste your dataset or your model's URL and save your username password who can log into this data set being set up, have permission to update the data set or database, and you're all set, right? So what happens, the schedule itself kick off all the full process, and it goes to the gateway in this case because the data is hosted locally as well, and they actually have multiple data sources, some from SAP, some from dynamic, some even from text file, Excel, CSV files. They have multiple sources in this case. So once all the data upload to the Azure Managed SQL instance, this API just kick in and refresh all the data. So you will notice the only difference in here prior to the prior example is they do have local database, all right, but they actually upload all the data to the Azure SQL instance first. So that's the only difference between the other samples. Because of this, the API itself, when you call your dataset refresh, we do not have to go through the gateway again. Only in the ETL process, we go through the gateway to upload the data to the SQL server. Okay, I think we may have some questions. Do we? John, do you see any question coming?
Yeah, I just want to remind people, we only got 2 minutes left here, but I do have one question, and if anybody has any more, please put them in the chat. So the first one, Susan, hopefully you can help with this one, is, so my data set is sourced from both on-premise and cloud data sources. So I have 2 different sources. Each has its own ETL schedule and data fresh frequency. What do you think are the best options to refresh my Power BI data set?
I think this will be very similar to the example we show here. You could using the TMSL script, XML endpoints, to control the table by different source. So essentially, you can refresh at a table level. Based on the source table schedule, you can have 2 scripts to run it at different time. That should work.
Okay. And I think we have time for one more here. And somebody's saying that what if my table structure changed, but the changes aren't reflected in my data set after I try to refresh on Power BI Online? How do I accommodate changes in table structure? Obviously, we could have more of a DevOps type thing here. Hopefully that doesn't happen in production, but what happens when I'm developing something and I have underlying changes to my data source?
Yeah, I think it's pretty common we see, similar to any BI, like a reporting, metadata modeling, similar concept here. If you do have your table structure change, you have to go to the source first. So essentially, I believe you have to go to your model. Either you're using desktop or using SSDT or Tableau Edit. You gotta open the model first. You gotta refresh the metadata because the metadata itself is being cached there. So you do have to refresh from here first, adding new columns or adding new tables first, and republish the entire model or data set. Once that is done, you will do a full refresh. As we mentioned in prior slide, right? Once you do full refresh, everything get refreshed, including the structure changes. After that, you can resume your incremental or daily, whatever schedule you have. That should take off, all the changes.
Okay, thanks, Susan. And I wanted to thank everyone else for participating or for joining us. This recording will be up on our website at some point soon. And as always, if you have any questions, please feel to email us individually or use the email you see up here on the screen. And please join us at some future sessions. At this point, next Thursday, I think it might be a slightly different time, as I had mentioned earlier, but we look forward to seeing you in the future here in the next couple of weeks and hopefully into the new year. If we don't cross paths, please, everyone have great holidays, and we'll talk to you soon. Thank you.
Thank you, everyone.